so our next speaker here, he's in town from Buenos Aires, which is pretty awesome. In town to talk to you people. Hopefully you will enjoy it. He's also active in the Node School and Vue.js community there. So a big community person, which is cool. We like those kind of people. So yeah, this is Nicolas Bevacqua.
Hi everyone. You look kind of like this right now, so I'm going to talk about yoga. He already introduced the topic a little bit, but I'm just kidding. So my talk is about high performance in the critical path, and that means serving applications fast and in a performant way from the server side and not just on the client side so much. This is something that I care about because I have this blog at Coneco.com, and when I first implemented it, it kind of took like 4 seconds to load, and meanwhile you had that spinner going around, which looked kind of nice the first 100 times, but then it was pretty awful. So I started getting into performance stuff, and this is what came out, I guess. So the first thing that you need to do to improve performance in your websites is to measure what's going on right now with what you currently have. And there's a lot of different ways you could do this. The easiest is probably using DevTools. They have an audit tab that you could just run and get a bunch of metrics out. These metrics tell you how caching is working for your site, if you're using gzip or not, whether you're minifying your scripts and your styles, and a lot of different things that you should be fixing. Another tool that you can use is PageSpeed Insights. This is a hosted tool from Google. You can go to that link. The slides are on Twitter, by the way, so you can just go to that account on the footer, and you'll open them in your computer. So with PageSpeed, you can just enter the endpoint for your website and click Analyze, and you'll get a bunch of metrics back after a while. They're divided between mobile and desktop. You get a score for each, and they have different scoring rules. Like for instance, for mobile, there are a couple of UX things that you should care about, like are my tab targets big enough for human fingers, or are they more like for mosquitoes? Then obviously mobile cares more about performance, so you have metrics like caching and stuff like that, and compressing images, and caring about what's visible in the first part of the application more than with desktop, so it's not as lenient as the scoring in the desktop app. And you also get a bunch of different suggestions on how to improve each of those things. Web page test is similar. It's also provided by Google. It's another hosted service. You also enter your URL to your website and click Start Test. One difference is that it takes a while because you're put into a queue and you have to wait until the queue clears up, and then the analysis takes a little bit longer too, but it's well worth it. You get a lot of different scores based on different aspects of your site. It analyzes connections in a very deep level, so you get a grade on the time to first byte, for example, whether you have keep alive enabled, caching, CDNs, compressing images and whatnot, and gzipping, of course. You have a bunch of different views, like this one, which is the waterfall view, and here, and here you can see that the different resources and how they block each other. So here, for example, you can see that the HTML is blocking on everything, then the CSS is blocking everything else, and then the fonts, and then finally the content finishes loading the images and stuff. So this makes it great to figure out whether, for example, you could load your fonts faster or asynchronously, and this way you would save half a second in your load time, for example. And it also gives you the same grace that we saw earlier, but per resource instead of just as an overall score. Another way of looking at the resources is the visual film strip view, and this is excellent at looking at how fonts render if there's a flash of unstyled text or a flash of invisible text. This makes it very easy to spot, and it gives you a percentage on each moment of the load time as the page loads, so you can tell roughly how much of the final content is loaded at any given point in time. It makes it very easy to spot flashes of invisible text, like I said. And the other thing is that it's used to calculate the speed index. And this is the visual progress of the visible page load time. And it's computed based on how quickly the content is loaded across time. So web page test gives you an inspection on a very deep level, even TCP traffic and the whole handshake connection, the SSL handshake, the TCP handshakes and whatnot. It helps you identify bottlenecks and it helps you visualize progress. So all of that was great, but in reality, if you just go back to your homes now and run through these tools once for each, in a month you're going to be in the exact same situation because you're not doing this enough. So what I'm proposing is that you automate this stuff. You need to measure early and you need to measure often, probably during your builds. There's a couple of ways you could do this. One of them is PSI. It's an NPM module that you can install as a command line tool. It also offers a programmatic API for Node, and you can integrate it with Gulp, Grunt, or whatever you need. As you can see on the command line, it has a list of the different things that you could see also on the page speed side. So look into it, and it's really pretty easy to use. Another tool that's not so easy to use but still worth mentioning is Web Page Test API. This one is kind of raw, and it makes you wait on the queue and call the API once and again until you actually get the results back. But you can wrap it and make a module that waits for you, so you don't have to do this every time. But it gives you a much more detailed insight into what's going on with your site, so you could maybe look into these incredibly big JSON blobs that it gives you and find the metrics that you find most interesting to measure and report during your builds. Wislow is another tool you could use for this stuff. It's a bit older, so I didn't bring it up earlier. But it also has Grunt and Gulp plugins, and you can run it on the command line as well using Pandob.js. The cool thing about measurements, once you learn how to measure performance, is also setting up a performance budget. And this really means making sure that you know where you stand with regards to your performance and how fast is slow. Right. So what kind of things can you track to say, okay, this is too slow, we're going to not deploy this build because it would affect performance and users too badly. So there's a few different things that we can track. One of them is milestones, and that's pretty basic. It basically relates to business metrics like the time to the first tweet that you display on your website. And obviously you probably don't have tweets on your website, but you might have a product or the headline for an article or things like that. The speed index is a great metric to measure because it's one of the most complete ones as a single value, because it gives you how the page is loaded over time and how much of the page is loaded at any given point. So it's a pretty good way of having a single overall value to use. If you want even easier metrics, you could use quantity-based metrics like request count, page weight, and things like that. Or you could also use rule-based metrics like the Y-slow or page speed or web page test grades. So there's a lot of different tools, different metrics to choose from, but you could use grant-perf budget to kind of like go through the options and figure out which ones are the best for your use case. But it really depends on the business that you have and the business metrics that you need to track that are important to you. So what can we actually do to improve performance besides measuring it? For this one, we should look at the whole web stack, starting with TCP all the way down to JavaScript. For the TCP and HTTP parts, you should probably read this book. It's by Ilya Grigorik of Google. He talks about TCP, HTTP, HTTPS, WebRTC, all these protocols underlying web browsers. And it also mixes that a little bit with UX and mobile networks, so it's a very interesting read, and I think one that most front-end developers should learn and care about. So when it comes to TCP, he basically offers two different insights that I think are pretty easy to implement, and we should do them because they produce visible performance improvements. So the first one is to increase the initial TCP window size, and this really means increasing throughput for the connection when it starts, and since the connection then ramps up the throughput, you get a much faster connectivity right at the beginning. So for that one, you basically have to have the latest operating system that you can on the server, preferably a Unix system, but depends on what your infrastructure looks like. And the other one is to disable slow start restart. You can use that command that's over there to disable it. Basically what it does is it plays against keep alive, because keep alive in HTTP basically means reusing the same TCP connection for multiple HTTP connections. And slow start restart, when a TCP connection is idle for a little bit of time, it goes back to save throughput values. And with HTTP, we have very bursty connections, TCP connections, if we have keep alive enabled. So it's kind of like a face-off. So disabling this is for the good of the web. HTTP, make less requests, right? Yeah, now we can go home now. This guy is awesome. So yeah, turn on keep alive so you can reuse TCP connections and not waste so much time doing handshakes, TCP handshakes in particular. Gzip the text so that images and scripts, HTML and whatnot are smaller. Add expires and ETAG headers were necessary, and make sure that your content is cached in a far future date, if possible. Use a CDN if you can. Look into it. It's some solutions are easier than others to implement, but you should at least look into it and see if it fits your business. HTTP2 speedy, yes, you should use this stuff. There's implementations that are already available for HTTP2, so you should look into that. If you're using NationJS or Apache, you can already use it. And speedy is basically the precursor of HTTP2, right? So what does HTTP2 mean? Basically it gives you non-blocking multiplexing, which means you can make a bunch of different HTTP requests at the same time on a single TCP connection that gets reused. So there's a single TCP connection per origin, and that really means we don't have to resort to hacks like domain sharding anymore to server images and stuff like that. That's kind of weird. In general, a lot of the hacks that we today consider best practices because of HTTP 1.1 are bad practices or meh practices at best with HTTP 2. Yeah. Yay us. Header compression is another big step up for HTTP. Basically what it does is it keeps maps of the headers that went out the last time and then diffs them and only sends the one that changed. This sounds kind of lame, but it's actually very useful for headers like cookies because they tend to be quite big, especially if they're going out in every single request. And then you don't have to use like cookieless domains, right? So again, same thing. Proactive server push is another very useful one. Basically, you send out the header in your from the server side, and you say, okay, when you fetch the HTML, I want you to fetch the CSS and the JavaScript as well, because I'm going to need this for the document. But the document hasn't even arrived yet. But the browser can still request those resources earlier, which is pretty nice. Because so far, we only had the HTML plugin and everything in the waterfall, as you can remember probably. When it comes to HTML, I say that we should render server-side first. And this doesn't mean that you can't use frameworks on the client side. It just means that you have to render something on the server that looks like what the user wants to look at, and then become a single-page app later. This is something that's possible using React and some other frameworks, as we'll see in a bit. But yeah, please do this. Defer non-critical asset loading, and we'll look at this later in depth, so I'm not going to go into it. So, optimizing CSS. Inlining critical CSS is something that I think is a big performance gain in HTTP 1.1 applications, and maybe even in HTTP 2 applications. How it works is, imagine if this was the viewport, the slide, the projector screen was the viewport. So everything that's below, imagine that's the rest of the slides, is non-critical because the user doesn't see it when he first loads the page. They just see this. So the critical CSS is the CSS that's necessary to render this as is without any regard for what's going on below. Like if he scrolls and there's comments below, they may be completely unstyled, and that's okay, because you want to show them what they want to see first, fast. And inline critical CSS is a great way of doing that. We'll look at ways of doing this later. Remove unused styles, again, later. Avoid them domains, be responsive so that you don't have to maintain many different versions of the same site. Concatenate and minify, obviously. Follow style guides. Seriously, like, yeah. Fonts. Load them asynchronously, please. Fonts are very expensive to load, so make sure that you load them asynchronously and that you load them once. Use fallbacks while fonts are loading so that you don't get flashes of invisible text, but instead make use of a font that looks kind of similar, and then go to the prettier one. Use fewer fonts and avoid repaints. Obviously, you have to talk to your designers about this first. It's not like you can remove their fonts and that's it. My work here is done. But in future projects, probably talk it over with your designer team and figure out whether you can use less than 3 fonts, say. And they'll probably be okay with it because this design is constraint-based. So they work great with constraints, so give them some, or many. Cache them aggressively, like I said earlier. When it comes to images, minify them and shrink them. Minification is something that's pretty standard nowadays, even though many of us still don't do it. So you should. And shrinking is something that I don't see come up a lot, but I think it's important as well. And this really means when there's a user uploaded image that's like a screenshot, that's like 4K by 3K pixels, yeah, your site's probably not going to need that many pixels. So if you shrink the image to say 1000 pixels by 800 or something like that, you're still going to render a pretty decent image, and it's going to be much faster to load. Defer images that load before the, below default. Again, this means loading them asynchronously. It's pretty easy to do in the most simple way. And it really depends on how your site works for more advanced use cases like fading them in or stuff like that. Create spreadsheets using tools, and don't ask your designers to put them together one by one because it's really obnoxious. Try inlining tiny dynamic images using data iris, and use CSS for simple icons like triangles and circles and whatnot. You can live without JavaScript there, I said it. By that I mean you should defer all of it, and your site should be server-side rendered, so it should work. Should. Use small modules, use asset hashing, cache vendor scripts separately. Again, all of that is pretty standard. Yeah, how the hell do we do all of this, right? So, I'm out. Okay, NationJS. It's a reverse proxy that gives you static asset caching so that you can do all of the first stuff we talked about. It supports HTTP2. It comes with gzip compression. It makes it very easy to configure it. So use NationJS as a reverse proxy, or use something in front of your Node application or your whatever application that makes sure that this stuff is covered. Set up a CDN if you have if you don't have the slightest idea of how CDNs work, just use Cloudflare. They basically take over your domain servers, and they copy all of your entries, and it works. So yeah, use that. Share rendering. You can use Backbone using render on the server side. You can use Angular maybe, I don't know, 2.0, who knows. React has native support. I wrote a thing that I'm not even going to name, but it has native support. And then there's Ember, which I think will eventually also, like Angular, it's like, who knows when, but it's supposed to be coming. So share rendering is a crucial aspect of server-side rendering, right? So probably use React, I don't know. Defer assets using async in your script tags. You can defer style sheets by adding an only X media type or something invalid like that, and then after a timeout, making it a valid media type. You can remove and use CSS using the uncss module. It comes with Gold, Grant, and whatever plugins. And just one line. And you can use this to get rid of Bootstrap rules that you never even use because you only included Bootstrap for the one button that you have in your site. Yeah. Inline critical CSS. This one's a bit of a hassle to implement. But there's this module called Penthouse, which basically runs through Phantom.js, and you give it the URL to your site and the path to your CSS, and it runs Phantom.js, which is a headless browser. It loads your site as if you were loading it in Chrome, and then it gives you back all of these styles that make up the critical content, so that all of the rest of the styles aren't returned by this output. So you can then inline all of the CSS that this tool gives you back into a style type, and load the rest of the CSS, the actual CSS resource file asynchronously. And what this gives you is a much faster rendering time, because you don't have to inline any styles. Hello, I'm going to stop soon. Font face and load. Yeah, just use this library, basically. You start with a website font, and then once the font successfully loads, this library will help you add a class name to the document, and then you can apply the custom font, because it's already loaded, so there's no flashes of anything. Optimizing images, you can use ImageMin for the optimization part. For shrinking, you can use graphics magic. It's also pretty easy to automate. For spreadsheets, you can use Spritesmith, and you just give it a folder with all the icons, and it gives you CSS styles, less, SAS, wherever, and the actual spreadsheet. For inlining, you can use DataUri module. You just give it the file name, and it gives you back the DataUri. And lastly, use a module system like Babel or Browserify or Webpack or something. Well, Babel is not it, but you got it. Yeah. So that's how you become awesome. You can use Perf School. It's a workshopper I made that has a lot of this content built into it. You can walk through it yourself. So yeah, give that a try. I wrote a book that kind of covers these topics. It's called JavaScript Application Design. You can go to that URL and get like 100 code samples for free. So thanks. If you have any questions, let me know.